Hello students, today we are going to discuss about the problems which were asked in JEE Main 2020 and the examination was held on 2 September in the first shift, and we are going to analyze the standard of questions and we are going to analyze the type of questions asked in that examination. So the first question here is that here the question is, arrange the following in the increasing order of reactivity with HCN. Okay, means this is the hydrogen cyanide. Hydrogen cyanide basically gives Cn minus as nucleophile. Cn minus as nucleophile. So here they are asking about the increasing order of reactivity with HCN. Means these are the compound A, B, C and D. And the question is that which one will react firstly with HCN, or which one will react rapidly with HCN, and which one will react slowly with HCN. Means we have to determine the order of reactivity with HCN. Okay, so what we have to do here is that actually firstly we have to see here in the option A, B, C and D. One thing is very common, and the common thing is that here there is benzaldehyde, there is like this CHO, and here it is OCH3. So here is partial positive charge and here is partial negative charge. This partial positive charge is basically electrophilic carbon. Okay, electrophilic carbon. So what happens here is that the nucleophile means Cl minus from HCN will attack at this, and this will break, and actually what will happen here, O minus and this H and this Cn and this OCH3, and after hydrolysis what we get? After hydrolysis we get kind of cyanohydrine here. So we will get this. So firstly we need to analyze the type of chemical reaction taking place here. Actually here is nucleophile, and here the pi bond is cleaved and two new sigma bond, one here and another here is formed. Means one pi bond, the pi bond between carbon and oxygen is cleaved, and in place of that pi bond we have two new sigma bonds. So one pi bond is converted into two new sigma bond. So anyone asks the type of chemical reaction, we can analyze that the chemical reaction is addition reaction, and since it is started by nucleophile, therefore we can say that the reaction, the category of the reaction here is nucleophilic addition reaction, no doubt. So the reaction is nucleophilic addition reaction. Nucleophilic addition reaction. So the type of chemical reaction going to take place between HCN and A, B, C, D means A will react with HCN to proceed to form cyanohydrine, and the reaction will follow nucleophilic addition reaction. So this will also react with HCN via nucleophilic addition reaction, and C will also react with HCN via nucleophilic addition reaction. So basically the type of chemical reaction taking place here is nucleophilic addition reaction. Now the question is, which one will react rapidly and which one will react slowly? Okay, so we have to decide. So first thing which we decided is the reaction is here nucleophilic addition reaction. Nucleophilic addition reaction. But they are not asking the type of the chemical reaction taking place. They are asking whether A or B or C or D will react rapidly or not. Okay, so see here, what is happening here? One thing we have to know here is that OCH3 whenever present in the ring, OCH3 whenever present in the ring here, OCH3 whenever present in the ring, like this is CH, this is CHO, and this is OCH3. Okay. So one thing we have to remember, that OCH3 can have plus R effect or plus M effect. We can say plus M effect. Plus M effect. OCH3 can have plus M effect. At the same time, OCH3 can have minus I effect, because this is carbon and this is oxygen, and there is difference of electronegativity here, and therefore this oxygen can attract the bonded electron towards itself, resulting into minus I effect. So what is happening here is that in case of OCH3 we have plus M effect and minus I effect, but plus M effect dominates over minus I effect. Means overall OCH3 here have two different effects. One is the electron withdrawing effect and other is the electron pushing, electron giving effect, means the plus M effect. So the overall effect here is that OCH3 have electron donating ability. Okay. So what is happening here is that we have two different effects. The first is the plus M effect and the second is the minus I effect. But here OCH3 have plus M more dominating than minus I. Therefore OCH3 have overall electron donating ability. So it will give electron overall. And here we have to also remember that here we have two different OCH3. One is at ortho and second is at meta position. So here it is at ortho position and here it is at meta position. So what is happening here? See here, in both the cases OCH3 will give electron to the benzene ring. Okay, and here also OCH3 will give electron to the benzene ring. But in meta position there is no resonance, only minus I effect. Only there is minus I effect, because we have to understand that at meta position there is only inductive effect. Only inductive effect. No hyperconjugation. And no resonance or mesomeric effect. Remember, at meta position there is only inductive effect, no hyperconjugation, no resonance here. So overall, what we have to see? We have to see that here there is aldehyde delta plus, okay, and here there is OCH3. Okay, so overall, and we have two different positions for OCH3, one at ortho position and second at meta position. Okay, so what is happening here is that this ortho position have plus M and minus I both, but what is more dominating? Plus M, means electron donating capacity of OCH3 is increased. When electron is donated here, means plus M more dominating from minus I. So overall, when electron is given to the ring, the plus charge here is decreased, and when plus charge here is decreased, the tendency to react with Cn minus decreases. So the rate of reaction decreases. So the presence of OCH3 gives electron to the benzene ring, thereby decreasing the plus charge on carbon, the partial positive charge on carbon, or decreasing the electrophilic character of the carbon present in this benzaldehyde present in this kind of benzene attached to aldehyde group. So actually what is happening here, OCH3 will decrease the rate of reaction, okay, and in case of here what we have only minus I effect, so it will tend to pull, because at meta position only minus I effect will work and no plus M effect will work here. So what will happen here is that this OCH3 will pull electrons towards itself, therefore increasing the electrophilic character of this carbon, and therefore when the positive charge increases here, the rate of reactivity with HCN increases. So if we ask that out of this A and B, which is more reactive towards HCN, which means which is more reactive towards nucleophilic addition reaction, so obviously B. So here in B we have minus I effect, here in A we have overall electron donating ability of this OCH3, decreasing plus charge, decreasing reactivity. But here in case of OCH3, only at OCH3 which is attached at meta position, only minus I effect is here, and therefore we can say that the electron pulling ability is here, and therefore increasing the positive character and increasing the reactivity. Okay, so out of this 1 and 2 we have clear. Now C and D. Now we have to analyze C and D. We have to analyze C and D. Okay, we have to analyze C and D. Okay, students, what is here in the C? See here. C is basically, this is a benzene attached to aldehyde group, and here at ortho position there is nitro group. Okay, and here is C option, and the D option is see here, NO2 produces minus M effect, NO2 also produces minus I effect. At which position? Ortho position. And here NO2 is connected to meta position, therefore we can say that only minus I effect is at which position? Meta position here. So what will happen? Remember, minus M minus I both are operating, therefore the electron pulling ability from the ring, means the tendency to pull electron from the ring is heavier here, is stronger here, means NO2 will pull the electron density towards itself, and when it will pull the electron density towards itself, the partial positive charge on the carbon increases. See here. So NO2 will pull the electron density towards itself. Now see here no minus M, because NO2 is present at meta position. At meta position there is no resonance, I have written here. So only minus I effect is here. So when only minus I effect is here, still it have electron pulling tendency, means it will withdraw electron density, and therefore when electron density is withdrawn, this plus character increases, means when electron is pulled from this ring, this plus will be increased. Electron is withdrawn, the positive charge, the partial positive charge will increase, therefore the reactivity will increase. So here reactivity will increase, here also reactivity will increase, But where more reactivity will increase here, two phenomena are operating, one is minus m and one is minus I. Here only minus I. So more electron withdrawing power is in case of C in compared to that of D. So if anyone asks that in which case the carbon have more increased partial positive charge, what you will say? So in case of C we have minus m minus I. It means the electron withdrawing ability of this NO2 is very stronger, making this partial positive charge very large, and therefore when the charge increases, the tendency to react with Cn minus increases. So reactivity increases. So if we want to draw the order of reactivity, so the order of reactivity here is first is this C, then D, and then what? Then this OCH3, because it still have minus I effect and not plus M effect, because it is at mid position. So B and at last A, because in A overall electron giving tendency is here due to plus M and minus I, which is dominating plus M. So electron donating tendency to the benzene ring is here, maximum here, and therefore the minimum positive charge on the carbon here. It is less reactive towards nucleophilic addition reaction. Therefore, if they are asking to arrange the following in the increasing order of reactivity with HCN, we can write C, D, B and A. Okay, so this has been completed. Now moving towards the next question here. Next question. What is the next question? Next question here. So the level of question was pretty good. Now moving towards next question, we have to see the next question. Next question is, what is the next question? Next question is, here is the reaction. This is perhaps question number 2. Here is a reaction, copper plus 2 plus stannum. This gives Sn plus 2 and plus copper. This is solid. Okay. 1m and this is 1m. And they are asking, and also given E naught Cu plus 2 upon Cu 0.34 volt, and E naught Sn plus 2 Sn, this is equal to minus 0.16 volt. So they are asking, what is delta G naught? Standard Gibbs free energy change. They are asking standard Gibbs free energy change. Standard Gibbs free energy change means what is given in the question. Actually there is a reaction and the concentration of this Cu2 plus is 1m and this Sn2 plus is 1m, and the standard reduction potential is of this copper is 0.34, and standard reduction potential of this stannous is minus 0.16 volt. These all data are given, and according to this they are asking that what is the standard Gibbs free energy change? How can we solve this? We have studied in the class that this is equal to minus NF E cell. This is the equation. NF E cell. What is this? Actually, N is number of moles, F is Faraday, nine 6,500 coulombs, and A cell, sorry, here is standard, is the standard EMF of the cell. Standard EMF of the cell. So this is the equation. This is the question of basically electrochemistry, and they are asking that if these data are given, these data are given, according to the data, determine the standard Gibbs free energy change. So standard Gibbs free energy change will be decided on this equation minus NF E cell. On which equation? Minus NF E cell. So how do we calculate it? Firstly, N here, see how many N? 2 moles. Actually what is happening here is that Cu2 plus will take 2 electron to give Cu. Okay. So what is the number of mole of electron? 2. Similarly, Sn will give 2 electron and plus Sn2 plus. So overall the mole of electron here is 2. Mole of electron exchange in the chemical reaction here is 2, and this is 96500 coulomb. What we need to calculate here is standard EMF of the cell. How to calculate standard EMF of the cell? Standard EMF of the cell is standard oxidation potential plus reduction potential. Very simple. Oxidation potential, reduction potential. Standard and standard. So see here, this Cu2 plus is changed to Cu, that means it is reduced. Its reduction potential is what? 0.34. So we will write here 0.34. And this Sn is changed to Sn plus 2. That means it is oxidized. So its oxidation potential is, see here carefully, it is oxidized, therefore we will write its oxidation potential, but here it is given in terms of standard reduction potential. So we will change, put a negative sign here. So if standard reduction potential of this Sn is minus 0.16 volt, what will be the standard oxidation potential? Minus of minus 0.16 volt. So basically E0 cell is 0.16 plus 0.346410 31415 0.5. So E0 cell is 0.5. Clear? Now see here, E0 cell is 0.50 volt. Now what they are asking? They are asking standard Gibbs free energy change. How we will calculate? N is 2, F 96500, and E cell 0.5, that means 1 by 2. 0.5 can be written as 1 by 2 for simplification. So we will get 96500. This is the answer. 96500 says since it is a standard Gibbs free energy change, its unit should be in terms of joule. So this is the answer. That's a pretty simple question. It was. So moving towards next question. I hope this question was very simple. We have to use that, and after that we will be able to solve this. Okay. Now moving towards next question. Moving towards next question. Next question is, Here we have next question. Next question is, when 1 mole of, this is perhaps question number 3, when 1 mole of Cl3 into 6H2 is treated with an excess of AgNO3 3 moles of Ag3L are obtained. The formula of the complex is, what is the formula of the complex? I am writing directly the answer. There are 4 different CrH2O5 Cl2 into H2. This is option A. This is option B. CrH2O Cl2 Cl into 2H2O, and option C. And D here, CrH2O3 Cl3 into 3H2. So looking upon the option, this is a complex compound. This is the question. The question is basically from coordination compound. So what is happening here is, if we give attention to the options, we get here this option. If the compound in aqueous condition, it will be dissociated like this. Now this compound, when treated with AgNO3, excess AgNO3, obviously AgNO3 excess. So what will happen? This is giving 3Cl minus. Excess means more than 3, 4, 5, 6 mole are there. Means more. There are a lot of mole here. Excess mole means a lot of mole are here. But out of this excess mole, only 3 mole of AgNO3 will give 3Ag plus 3NO3 minus. So this 3Ag plus will be combined with Cl minus, giving 3AgCl, and this 3NO will be combined with this part, giving CrH2O whole 6 NO3 and whole 3. Means overall what is happening here is that CrH2O whole 6 Cl3, when react with 3 mole of AgNO3, how many mole? 3 mole. Then what we are getting? We are getting CrH2O 6 NO3 whole thrice and plus 3 AgCl. So obviously this is the molecular formula can be written. This molecular formula can be written as CrCl3 into 6H2. So this is the complex which is, when treated with excess of AgNO3, gives 3 mole of AgCl and 1 mole of this complex. Okay. So the question was, when 1 mole of this one, means that one is treated with excess of AgNO3, 3 moles of AgCl are obtained, and 3 mole of AgCl is only obtained when we have this 3 mole of AgNO3 which is treated with this kind of complex. So the answer will be C. Answer will be C. That is a very simple question. So moving towards next question. Moving towards next question. Next question. Next question is perhaps question number 4, and 5 moles of air, argon, and 3 moles of O2 are mixed. O2 are mixed. Find the total internal energy terms. Find total internal energy in terms of RT. In terms of RT. See here, the question is, there are 2 different gases. One is argon and the second is oxygen. Different moles of them are given and they are mixed. Then they are asking the total internal energy in terms of RT. Okay. So how we will solve? Before we go to solve the problem, we should know that argon is monoatomic, and O2 is diatomic gas. O2 is diatomic gas. So we have seen in many problems, we have conceptual idea that monoatomic gas have degree of freedom 3. Degree of freedom 3 means its degree of freedom is represented by F. So this F is equal to 3. And here, in case of O2, the degree of freedom is 5. Degree of freedom is 5. Now, when mole and degree of freedom are given, and how to calculate the internal energy? Internal energy is calculated as N into F by 2 RT. Remember, a very important formula here. This N is mole, this F is degree of freedom, R is gas constant, and T is temperature. So here for oxygen, for O2, internal energy will be what? How many moles of O2 are there? 3 moles of O2. So 3, and how many freedom degree of are there? 5. 5 by 2 RT. Okay. And for, so this is basically 15 by 2 RT. And for argon, internal energy is N. What is N? How many moles of argon are there? 5 moles. How many moles of degree of freedom? 3 moles. So this is again 15 by 2 RT. So if we calculate this internal energy delta U1 and delta U2, total internal energy change will be total. This is equal to 1 plus internal energy change 2. So 15 by 2 RT plus 15 by 2 RT, that means 15 RT. So total internal energy change when the two different gases like argon and oxygen are mixed will be 15 RT, where T is the corresponding temperature and R is the gas constant. So this will be the change in internal energy when two gases argon and oxygen are mixed at a temperature T where the gas constant is R. And here also we have to remember this is only valid when 5 mole of argon and 3 moles of oxygen are mixed. Okay, so this is okay. This is completed. Moving towards the next question. We have second question. We have second question. We have the second question. Okay. Now the second question is from organic chemistry. Question number perhaps 5. Question is on benzylamine can be. The question is benzylamine can be alkylated as shown in the following reaction. Benzylamine can be alkylated as shown in figure, as shown in the following reaction. This is benzylamine plus Rx. Which alkyl halide is best suited? Which alkyl halide is best suited for this reaction? Through SN1 path. We have option A, CH3Br, B, C6H5Br, C, C6H5, CH2Br, and D, C2H5Br. This is the question. Means here when benzylamine is treated with alkyl halide, then this R group is linked to this nitrogen atom. Means what is happening here is that this R is going to this end. The overall observation is the alkyl group is shifted to this N. Therefore, we can say that benzyl amine has been alkylated. And the question is also that benzyl amine can be alkylated as shown in the figure. Which of the following alkyl halides? The question is that which of the following alkyl halides is best suited through the SN1 mechanism? How to solve the problem? There is a question. The question is that firstly, before we go to answer this question, we should know about the SN1. What is happening in that? In SN1, alkyl halide in SN1 path gives stable carbocation. Stable carbocation. If there is a kind of this alkyl halide, this will through SN1 give stable carbocation. This is resonance stabilized, therefore stable carbocation is here. Now the question is that how the process of alkylation of benzyl amine takes place so that this R is attached to H. What is happening here? See here. The thing which is happening here is that this is benzyl amine, I am writing here. This is lone pair, this is, now see what is happening here. The thing which is happening here is that the alkyl halide through SN1 mechanism is cleaved at R plus and X minus. R plus is a stable carbocation. Remember, the Rx when undergo cleavage through SN1 mechanism, what it gives? R plus and X minus, and this R plus is a stable carbocation. Remember, it is a stable carbocation. Stable carbocation. So what is happening here is that this X minus is coming to this H, and this H is giving the electron to nitrogen because the electronegativity of this nitrogen is greater than that of H. The electronegativity of nitrogen is greater than that of H. Therefore, it will pull the electron. It will pull the electron towards itself. So this X minus will go to H, forming HX. And what we have? Let's see here, the one lone pair was from initially, and after the taking of this electron from hydrogen, this electron will also come as lone pair, M minus, and this is H. Now R plus will come at this minus, forming this. So here in the reaction mechanism, what we have to see? The first thing we have to see is that the alkyl halide when SN1 mechanism, when proceeds through SN1 mechanism, give a stable carbocation and X minus. This X minus will go to the hydrogen of benzyl amine, thereby giving HX and one minus charge on nitrogen with two lone pairs. One which was from very beginning, and the second due to cleavage of the bond. Now R plus attack at this. And finally, there is alkylation of benzyl amine. So in the entire process, we have observed that the alkyl halide must be such that it is able to give a stable carbocation. Here, in the option, if we visualize the option, this will give CS plus, CS3 plus. If the bond is cleaved like that, no stable carbocation. This bond will be not cleaved due to partial double bond character, no carbocation. This will give plus like this, CS2Br, CS2Br, and when it proceeds through SN1, it will give this benzyl carbocation. And this benzyl carbocation is resonance stabilized, therefore it is a stable carbocation. This is ethyl carbocation, not stable. So what we have? Only one stable carbocation. This is benzyl carbocation. When the stable carbocation will be established, will be formed, then X minus means the Br minus will go to what? This H, giving HBr. Now see here, in place of X minus, what we are here? We have Br minus. So Br minus will give and gives HBr. And in place of R, what is going to be attached? R, in place of R, what is going to be attached? This is going to be attached. This is going to be attached. Means overall, if we want to draw the sketch or to sketch the mechanism, what will happen here? What will happen here? See here. What will happen? We have a kind of this carbocation, this alkyl halide. When it proceeds through SN1, we have benzyl carbocation and this Br minus. Now this Br minus goes to see here, this lone pair of electron is from very beginning. This Br minus will go to this hydrogen and this electron will go to nitrogen, giving back now at this will attack, and finally we will have this will be the compound. So in this way we can sketch the mechanism of the reaction here. So I think this is also clear. The question was not difficult. The problem was to deal with the stable carbocation. The problem was to deal with how the alkylation process of benzyl amine is taking place. There was need to describe it, or there was need to explain it. We have explained. Okay. So moving further. Moving further, second question is find the number of chiral centers. Question number 6 perhaps. Find the number of chiral centers. In penicillin. the structure of penicillin is. No. Actually, the structure is disturbed here. The structure is disturbed here. The structure of penicillin. See here, this is the structure of penicillin. Okay, this is the structure of penicillin. Here are COO, NH, and this CH, COO, N, CH, S, S, C, double, CH3, and COOH. So the question is that in the structure of penicillin, how many different chiral centers are there? So in order to answer this, we should know about the chirality concept. Actually, in order to decide the chiral center, the carbon must be tetrahedral. The carbon must be sp3 hybridized. The carbon must be sp3 hybridized. So here the carbon is sp3 hybridized. If we see all the valency must be, all the tetravalency must be non-identical. Valency must be non-identical. If we have tetravalency, the tetravalencies should be completed from 4 different groups, and the carbon should be tetrahedral, means sp3 hybridized. If the carbon is sp2 hybridized, we are not able to decide the chiral centers and all. So here this carbon is sp3 hybridized, and the 4 valency, one valency is completed by this group, another by this, and the other by this, and the second by this. So this is the chiral center. Is this the chiral center? Is this the chiral center? C attached to CH. So this is the chiral center again, because one group is attached by S, one is by H, one by N, and another by CH. This is also chiral center. And if we decide here, this is not the chiral center because 2 identical groups CH3 is attached to that same carbon. Here the carbon is attached to 4 different groups. The one is N, the second is H, third is the COOH, the fourth is this. This is again chiral center. So in the structure of penicillin, we have kind of 3 different chiral centers. So the answer is 3 chiral centers. 3 chiral centers. 3 chiral centers. Okay. Now moving further, this question has been completed. This question has been completed. Now moving towards next question. Moving towards next question. Question number 7 is here. Uncertain in position of a particle is 10 to the power minus 15 meter, 10 to the power minus 5 meter. The uncertainty and its velocity will be A 1.2 into 10 to the power 34, B 2.1 into 10 to the power minus 26, and C is 1.6 into 10 to the power minus 20, and D here is 17 into 10 to the power minus 9. How to solve the question? Actually, the question is from Heisenberg uncertainty principle. Heisenberg uncertainty principle, according to which delta x into delta p, this should be this greater than equal to h by 4 pi. This was the statement of Heisenberg uncertainty principle, that a location and the momentum both cannot be calculated simultaneously. If there is effort to calculate, there will be some kind of error there. So here this is बहुत heavy. Okay, so here uncertainty in position. So if we change delta x into m, p is equal to m delta v, this should be h by 4 pi. So they are asking that uncertainty in position of a 0.25 gram particle is means uncertainty in position. They are giving delta x to be 10 to the power minus 5 meter, and they are asking the uncertainty in velocity. So what will be the value of uncertainty in velocity? H by 4 pi m into delta x. So delta v is equal to h upon 4 pi and m. What is m? 0.25 gram, and 0.25 into 10 to the power minus 3 kg. And what is delta x into 10 to the power minus 5? Putting the value of these constants, 6.6 into 10 to the power minus 34 joule second divided by 4 into 3.14 into 0.25 into 10 to the power minus 3 into 10 to the power minus 5. Solving this, you will get this 2.1 into 10 to the power minus 26. 2.1 into 10 to the power. So the answer will be 2.1 into 10 to the power minus 26. This is the uncertainty in the velocity of the particle. This was very simple question. Okay. Now so here in the question, it is given that this compound undergoes treatment with this H plus followed by heating, and we have to find it out which of the following options are correct. Option number A, B, C or D. So firstly, in order to solve the problem, we should write the mechanism. The mechanism here is what will happen, see here, when this H plus will come, so it will be attached at here or here. Suppose this H plus is attached in the form of H here, then plus charge will arise here. Means if there are two H, see here, there are two H here, hidden H, we have to understand it. There are two hidden H here. So when the third H comes here, 2H was already there, and this H plus comes here, so 2 electron will go to that H plus, neutralizing it, and this H plus is added here in the form of H. Now when at this carbon hydrogen is added, means H plus is added in the form of H, then the plus charge will be here. And if the H plus is added in the form of hydrogen here, then plus charge will be there. Means there are two H, there are one H here, one H already, and one H now added. Here are two H and one plus. So this is less stable, 1 degree carbocation, and this is 2 degree carbocation. So this is more stable and this is less stable. So we will take this into consideration, means when H plus attacks at here, then 2 degree carbocation will be formed here. So this is taken into consideration, more stable, and this is less stable. So we will consider this. Now what happens after this? We have to see here. What happens after this? So we have considered here that we have considered here the more stable carbocation. So the more stable carbocation corresponding to this is this. Okay. Now see here, there is kind of ring expansion here. There is ring expansion here. This is 2 degree carbocation, more stable. Now see what happens here. Let number this to be 1, 2, 3, 4, 5, 6 and 7. Now what happens here? This there is a ring expansion, means in the ring how many carbon atoms are there? So 1, 2, 3, 4, 5. 5-membered ring is here. So there is ring expansion. So what happens? These 2 electrons goes there. These 2 electrons goes there. When these 2 electrons goes there, this bond is cleaved and the 2 electrons goes there, then partial positive charge is here. So a kind of ring expansion is there. See here. This is the carbon number 3. So carbon number 3 contains a methyl group, and here there is plus charge. Okay. So this is this, and there is a linkage between the carbon atom number 7 and carbon atom number 2. See here. This was 1, 2, and this was 3, 4, 5, 6, and here 7. So there is linkage between number 7 and 2. This. There is linkage between number 7 and 2. So if you analyze here number of carbon atoms in the ring is here 1, 2, 3, 4, 5, 6. So this is similar to kind of, this is 2 carbon, this is 3 carbon, this is 4 carbon, this is 5th carbon, this is 6th carbon, and this is 7th carbon, and this is the first carbon, and on 3 carbon there is methyl group. So this is basically, and there is also charge. At 3 there is positive charge. So this and this are equivalent. So numbering, don't think that I have done numbering in wrong manner. Actually I have done the numbering in order to understand, in order to know that the carbon number 7 is connected to the carbon number 2. Therefore we have make a bond between carbon number 7 and carbon number 2. So in this ring there are 6 members, 1, 2, 3, 4, 5, 6. 6 members are here. Now what happens here? So can I erase this? Yes, I can erase this. After ring expansion, now we have this, means this, and here there is plus. So after ring expansion, what will happen? See here, there is one H here. So what will happen? This H will go in the form of H plus when heated, minus H plus, means what is happening here? A kind of elimination reaction is taking place here. So what will happen here? And there is development of new bond between this. So this is the answer, and this answer is actually the option number D. If you will see here, this is equivalent to option number D. Means what I have solved and I have given the answer, it is this and this, which is equivalent to this. This and these are same. So what will be the answer of this question? The answer of this question is D. So firstly, what we have to do? Firstly, we have to treat this compound with H plus, and after treatment with H plus, there will be formation of carbocation. There are two possibilities. One gives more stable carbocation, and another gives less stable carbocation. So we will consider more stable carbocation, and after that we will consider ring expansion. And after ring expansion, we will get this compound. After ring expansion, we will get this, and after deprotonation, we will get this alkene. Basically, we get alkene as the final product. So this D is the correct option to the question. Okay. So I hope you have understand this. Now we have next question here. The question belongs to the thermodynamics chapter. So the question is calculate delta U. Delta U means change in internal energy for the vaporization of 90 gram H2 at 108 degrees C. Given enthalpy of vaporization is 41 kilojoule per mole and the value of R is given here. So we have to find the answer. So what is the vaporization process? The vaporization process is 1 mole of a liquid when converted to 1 mole of a gas, then the enthalpy change corresponding to this process is known as enthalpy of vaporization. See here, this is 1 mole, so delta Ng is what? Actually here the number of gaseous mole is what? 1 mole. Okay. So delta U they are asking, and mole of water, and 90 gram. See here, water is 90 gram. So mole of water is 90 by 18, that is 5 mole. Now see here, when 1 mole of a liquid water is converted to gaseous, then what amount of enthalpy is again? 41 kilojoule per mole energy is taken. This is the enthalpy of vaporization. Now the case here is we have to determine change in internal energy. So from the concept of enthalpy, from the concept of enthalpy, we know that delta H is equal to delta U plus delta Ng RT. See here, this delta H is enthalpy change, this is internal energy change, and delta Ng, we have to remember here, delta Ng is number of mole of gaseous product minus number of mole of gaseous reactant. Here this is delta Ng. Remember, change in mole of gaseous product means change in number of mole of gaseous elements, that means number of mole of gaseous product minus number of mole of gaseous reactant. So if here we want to consider delta Ng, what is delta Ng? Number of mole of gaseous product, what is mole here? 1 mole. And number of mole of gaseous reactant, no reactant is in gaseous form, only in liquid form, so it is 0, so delta Ng is 1. So basically from this equation, if we want to write about change in internal energy, it is delta H minus delta Ng RT. Okay? So this is delta H 41 kilojoule per mole, okay, minus delta Ng1 R. Here we have to remember that the value of R is 8.314 joule per Kelvin per mole. But if you want to write this R in terms of kilojoule per mole, so we can write 8.314 into 10 to the power minus 3 kilojoule per mole. We can write kilojoule. Now here it was joule per Kelvin. Now we have written kilojoule per Kelvin per mole. It is joule per Kelvin and this is kilojoule per Kelvin. And we have written kilo, we have multiplied with 10 to the power minus 3. So if you want to write R, what we can write? 8.314 into 10 to the power minus 3. So what we will get? If you will calculate this, let me calculate. So if you will calculate this, you will get 3.314 if you will calculate, you will get 3.1. 3.1 means 37.9. This is the change in internal energy. But remember that this change in internal energy is for 1 mole of water. 1 mole of water. But here how many moles of water are given? 5. So for 5 mole of water change in internal energy, that is equal to 37.9 into 5. 9 5 ja 45 and 3 7 5 ja 35 4 39 and 5 3 15 and 3 18. So this delta U is 189.5. This is the actual answer. This is the actual answer, okay? So I hope 189.5. So I hope you would have understood this. So here another question is, which of the following graph is incorrect for ideal gas? Means see here, the T is temperature and D is density. Remember here, this is small d is density of the ideal gas. This D is the density of ideal gas and T is the temperature of the ideal gas. So keeping these two things in mind, we have to plot a graph and we have to recognize which graph is incorrect regarding ideal gas. So before we solve the problem, please go to the ideal gas equation. From ideal gas equation, PV is equal to nRT. Okay, this is volume, and volume is equal to mass by density. Remember, mass by density, because we all know that density is equal to mass by volume. So volume is equal to mass by density. This is equal to nRT, and if we write here D and temperature, okay, so if we write here PM by RT, nRT, this is equal to D. Okay, so D is equal to PM by R into 1 by T. Remember here, D is density, P is pressure, M is mass. M is not molecular mass, M is mass. Remember, M is mass of gas. So here D is equal to PM by R into T. So we are observing here that at constant pressure the entire term is constant, because pressure is constant. If pressure is kept constant, the pressure is constant, mass is constant, and R is gas constant, which means the entire term will be constant. So this D is equal to constant into 1 by T. That means D proportional to 1 by T. D proportional to 1 by T means D is inversely proportional to T. So we can write here D is inversely proportional to T. So this equation is this graph is correct, because the inverse relation of the temperature and the density can be best explained by this graph. And also D is directly proportional to 1 by T. So if we are taking 1 by T here in place of temperature here, so there will be a straight line. There will be, actually I have missed something. This is like this. So if we are putting here 1 by T and here D, so D is directly proportional to 1 by T. That means a density is directly proportional to 1 by temperature. Is that clear? So we will there is a directly proportional relation, so definitely we will get a straight line. So this is a straight line equation, D proportional to 1 by T. So this is also correct. This is incorrect, because density is not directly proportional to temperature. This graph is saying that D directly proportional to T, but we have calculated here that D proportional to 1 by T. Definitely this graph gonna wrong. So this is incorrect graph. This is incorrect graph. So I think that you all are understanding these all things, and the question is of very moderate category. It was not very tough question, it was a very easy question. So here we have another question, and the question is that for the graph x by m versus log p, okay, has slope is equal to 2 and intercept is equal to 0.477. Find the value of x by m at 4 atm pressure. Actually the question is from Freundlich adsorption isotherm. The question is from adsorption chapter, and Freundlich adsorption isotherm. Basically, there is a topic there, and the question is from that topic. So, according to Freundlich, x by m directly proportional to p to the power 1 by n. Okay, where x by m is what? Mass of gas adsorbed. Mass of gas adsorbed. Adsorbed per gram of solvent. Per gram of solvent. Per gram of solvent. And P is the pressure. So if we move from here, if we remove the proportionality sign, definitely we have to put here constant value K, P to the power 1 by n. Remember, this is Freundlich adsorption isotherm. So if we want to put a graph, if we want to draw a graph according to this equation, what we have to take? We have to put down this 1 by n, and in order to put it down, we have to take logarithm. So taking log x by m, this is equal to log k plus log p to the power 1 by n. So this ultimately gives log k plus log 1 by n will come in the form of multiplication. So we will have log x by m is equal to log k plus 1 by n log p. So if we rearrange it, see here, this comes in the form of y is equal to mx plus c. So the slope is 1 by n and the intercept is log k. So according to this graph, along y-axis log x by m is there, along x-axis log p is there, and intercept here is log k, and slope here is 1 by n. Now according to question, the slope is, now according to question, we can erase this. Now according to question here, what we are gonna see, so according to question, given that the slope is equal to 2, means 1 by n, the slope here is 1 by n and the intercept here is log k. So the slope is equal to 1 by 2 and 1 by n is equal to 2, so n is equal to 1 by 2. Okay, and the intercept means log k is equal to 0.477. This is the value of actually log 3, so k is equal to 3. So we have got two number, one is the n and another is the k. Now we know that x by m is equal to k into p to the power 1 by n. Now x by m is equal to, they are asking the value of x by m at which pressure? 4 atm pressure. So x by m is equal to k, and what is k? 3, and p is 4, and 1 by n. 1 by n is 2. 1 by n is 2. 1 by n is 2, 2, 2. Okay. So what we will get? X by m is equal to 3 into 4 4 is 16. 16 and 3, 48. So we have answer 48. 48 is the right answer here. 48 is the right answer here. Okay. So this was about to ask. Now the question is, if anyone want to know the graph of this kind, means the graph corresponding to this equation, what will be the graph here? What will be the graph here? Let me draw the graph here. Graphically, here there is log p, and here there is log x by m. So graph will be like this. This is the intercept, which is log k, and this is the theta is equal to tan inverse slope 1 by n. This is the graph of that kind. So I hope you all have enjoyed the questions of JEE. That was the overall explanation indicates that the question was of moderate to easy type, easy to moderate type. There was no question which was of very hard nature. So I think you all have enjoyed the way we have solved the problem. So this is all about the first shift. Now we are coming soon for the next shift of JEE examination. This was all about 2 September first shift. Okay. So hope you all have enjoyed these all questions. Okay, take care and meeting soon in the questions of next shift. Okay, bye bye, take care.